Welcome to physics laboratory class. Today I am going to explain about the experiment, that is torsion pendulum. Then what is the use of torsion pendulum? It's a aim. What is going to be find out with the help of the torsion pendulum, that is aim. So first we want to write the aim. So aim nothing but question. You just rewrite the question with the beginning to determine, like that. To determine the moment of inertia. So with the help of this torsion pendulum, we are going to find the moment of inertia of the moment of inertia of the disc. So here disc is there, no, this disc, moment of inertia of disc, and rigidity modulus of the material of the wire. So here one wire is there whose rigidity modulus, that means the wire made up of some material, rigidity modulus of the material of the wire. So these two things is going to be find out. So what is aim? Aim, that is to determine the moment of inertia, the moment of inertia of this particular disc and the rigidity modulus of the material of the wire. So this is the first part, aim. So immediately after that aim, you just put the subheading, that is apparatus. So what are the apparatus required to demonstrate this particular experiment? So the apparatus you just see here, this is a wire, this actually steel wire or copper wire, anyone. So this is made up depending upon the material we use. So circular metallic disc, one wire, suspension wire, then balance, here digital balance. So for finding this weight, the weight of the disc is going to be find out separately. So that weight already find out, they mention sometime they will give in the initial stage also. If not provided, you can find the mass with the help of the digital balance. So the digital balance is need. Then meter scale, 1 meter scale is need. Then about the stop clock to measure the time period of this oscillation. Then one screw gauge is need. Screw gauge that is used to determine this radius of the particular wire. So these are the apparatus. So we put the subheading apparatus required. So what about the apparatus? What are the apparatus needed? Circular metal disc, suspension wire, then the other things balance, that means digital balance, meter scale is required, stop clock is there, screw gauge and the thread. Thread is used to find the circumference of this disc. To find the circumference of disc, from that radius of the disc is going to be find out. So these are the required apparatus. Then you move to the formula. So what are the formula is going to be used in this particular experiment? The first formula is to finding the moment of inertia of this particular disc, that is I is equal to mr square, because this disc is a circular metallic disc. For circular metallic disc whose moment of inertia is going to be find out, I is equal to mr squared by 2. That is I is equal to mr squared by 2. M, that is mentioned here, mass of the circular disc, or that is radius of the circular disc. So this is moment of inertia formula. Then the second formula is rigidity modulus of wire, that is 8 pi L, that means 8 pi I. Here I is the moment of inertia already find out. Okay. Then R is the radius of the wire, that can be find out with the help of the screw gauge. Then L by T squared, that's the result we already found out from this experiment. L by T squared, length of the pendulum, and T is a time period. So with the help of this one, rigidity modulus of the material of the wire is going to be find out. So the third subdivision is formula. We want to write this formula with the explanation of the individual letters. So this is about the formula. So after writing this formula, you want to draw this diagram and also the tabular column without this data. So after doing the experiment, you want to fill the table, that means data. Initially, before getting sign from the invigilator, you should draw this diagram and these things, serial number, length, time of 10 oscillation, time period for 1 oscillation, T squared, L by T squared, and this column everything. No need to fill this number in the initial stage. The number is going to be filled after doing the experiment. That's very important things. With if the initially the data filled means that is malpractice, because there is no possibilities of filling this data without doing the practical. So no need to fill the data initially. After doing or after setting up the experiment and doing some experiment values, then only want to fill that tabular column values. Okay. So this is a tabular column 1, and the number 2, the second tabular column for finding the radius of the wire using screw gauge. So screw gauge tabular column, where the least count of screw gauge, 0 error is going to be find out in the initial stage. So after fixing screw gauge like this, you can find the 0 error. How to find the 0 error? You know, a pitch scale, one line is there. If this line is below the 0 of main scale or above this 0 of main scale, the 0 error is going to be find out. If the line is above, means above the 0 of main scale, that means Hertz scale, then we can measure it is that means 0 above means the line 0 above means that is 98, like that 98, 97. So that is a negative 0 error. Negative 0 error. Suppose 98 is inside this line means negative minus 2. Then 0 error minus 2. 0 correction is plus 2. Like that the 0 error is initially going to be find out, and the values are mentioned here. Then also this tabular column. So after completing this tabular column, you get the signature from the invigilator, then you will do the experiments. Now move to the experiment part. So this is a arrangement, that means torsion pendulum arrangement. One disc is there that is suspended with the help of the wire. Okay. So after setting up of this arrangement, a small turning, so you can fix like this. So before fixing, you can measure this length of this particular torsion pendulum disc. Here it is 60. And, so we'll start the reading from 60 onwards, or maybe start from the 50 initially. So measurement is from here to here. This length of the pendulum is initially set. Here I set it as a 60 centimeter. Okay, so the initial arrangement is this one. Then after setting up of this length, you just rotate. You see, a small rotation is given like this. You just rotate like this and fix it in that position and let it free. So it's going to be rotated. That we called oscillation. That's oscillation. So from this oscillation is continuously going on. This oscillation, we mention the oscillation, how many oscillation is completed. For finding that, we should mention one point by using chalk piece. Here we make one point, the help of chalk piece. Then if this chalk piece value, that chalk piece marked value come here, then after turning once again come to the particular place, that is one oscillation. Okay, from suppose here the chalk piece mark is there, one turning left and one turning in right, that is the completion of one oscillation, like 10 oscillation time period. So want to find the time period by using this knob. That means when it move in the upward direction, the time is going to be counted. So this time is going to be measured up to the 10 oscillation. So when the 10th oscillation is going to be completed, we can just lower this value. So after 10 oscillation, whatever the measurement is going to be recorded in this particular clock is going to be measured and directly entered here. In this particular tabular column, the first one here it is 50th centimeter. So I set it 60. So in the 60th centimeter, the corresponding value, time period. This is a trial number 1. the same trial or the same 60th centimeter that experiment is going to be repeated once more. That is trial number 2. So like that 4 times the experiment is repeated by lowering or raising the position of this that means wire. So with the help of this knob we are able to release this wire. If released, the wire length is going to be increases. Then you set it as 70, 80, 90 like that. For every time the time period for 10 oscillation. How to measure 10 oscillation? You see here, this is a chalk piece mark. So chalk piece mark is there. So once again I repeat that experiment. So just hold this particular disc like this. Then a small rotation is given. So you see here, this is a chalk piece mark. So after releasing, you just explained it. So after releasing, the chalk piece will come to here. So up to this. Okay, then one left and one right. So now the one oscillation is over. Then one left, then the right. The second oscillation over. So for mention, for our understanding, we should mark any one line here. So like way the 10 oscillation is going to be found out. So the care should be taken, that means while this oscillation is going to be happen, the same time this like oscillation is also may be possible if the disturbance is not proper. Like that means it's going to be entire arrangement is going to be oscillated. That should be avoided. That should be avoided. So you need to rotate this disc alone, not the entire arrangement. So that is a care. So like this, the particular disc alone going to be rotated. From that the 10th oscillation is going to be corresponding time period is going to be calculated. So the values are tabulated in a first tabular. Like this, the first tabular column is going to be filled. Length that is going to be adjusted by using the knob. Then 50, 60, 70, 80 corresponding time period for 10 oscillation. Trial 1, trial 2, then mean, then average of first, second trial. Then this is a time period for 10 oscillation. That means, this is a 10 oscillation. Here time period for 1 oscillation. That can be find out by dividing this number by 10. That is 45 divided by 10, 4.5. 49 divided by 10, like that. So from this t squared is going to be calculated by using calculator. Then L by t squared. This L value divided by t squared value. So average L by t squared, we have two values. Average of this one is mean value of L by t squared. That is L by t squared. This is a very important one. This would be used in a formula. Okay, so this one over. Now I move to the second tabular column. So how to fill this second tabular column? The second tabular column measurement is going to be taken by using this way. So just we release this that means screw gauge and hold like that. We can find this radius of this wire. So just look at this. This particular wire is going to be in between these two jaws. So now almost close. So you just keep it. Now it's going to be closed. Then holding the particular wire by this screw gauge. Now the measurement is going to be taken by using this that means pitch scale and head scale reading. So this lower scale is pitch scale, this one is a head scale. So here you see pitch scale reading is actually 0. Only the 0 is visible. See here, 0, the pitch scale 0 only visible. So the pitch scale reading is 0. Then how to find the, that means head scale reading, head scale coincident. The head scale coincident means the pitch scale line is coincide with the any one line of head scale. That is the head scale coincident. Here it is almost, the value is what? That is 20, that is 90, okay, 90. Okay, 90. Or 90, here it is just below 88. That is what? The particular head scale coincident. Okay, so see here, head scale, pitch scale is 0, head scale coincident is, that is depending upon the wire, 89, and head scale reading. How to find head scale reading? Head scale coincident 89 into least count, 89 into least count, that is a head scale reading. Then observed reading is sum of the first column and third column, that is pitch scale reading plus head scale reading, 0.89. So like that the experiment is repeated 3 times or 4 times, the value is, so how to experiment repeated, you just see, so initially you can measure the radius from here, then the second measurement by moving that pitch scale and holding the wire in another place. So here we find the radius. Like that 3 different places of this particular wire where the radius is going to be find out. It means directly you can find the diameter. From the diameter, half of the diameter is radius. So observed reading is there. Observed reading is sum of the pitch scale reading and head scale reading. Then this is a corrected reading. What is mean by corrected reading? Corrected reading nothing but observed reading plus or minus 0 correction. So in our case the 0 correction is negative because 0 error is negative, so 0 correction is positive. So you want to add this 0 correction value. So corrected reading is equal to observed reading, then correction plus mean you want to add, correction minus mean you want to subtract it. So like that you want to fill this last table column. So average of this gives diameter. Average of this gives diameter. From this diameter radius is going to be find out. Radius is r is equal to d by 2. That is radius. So observation everything over. Now we move to the calculation. You see the mass of the circular disc is found out with the help of the digital balance, that is 1.1 kilogram. 1.1 kilogram. Circumference of the circular disc, that is going to be find out by using the that means twine, that is 39 into 10 power minus 2. I initially mentioned what is the uses of circumference. From that radius of the disc is going to be find out. Circumference is 39. So how to find the circumference? You see here the entire disc, that is find out by using the twine. So that is circumference. 39 into 10 power minus 2. So radius of the disc is circumference, that is circumference by 2 pi, because circumference is equal to 2 pi r. So circumference is equal to 2 pi r. So r is equal to circumference by 2 pi. So the value is there. This is radius of disc. Then radius of wire is taken from this tabular column. Then mean value of L by t squared is taken from the first tabular column. So these are all the datas. So using this data you can find the moment of inertia I is equal to mr squared by 2. This capital R radius of the disc, small r radius of the wire. Okay, so you can find out this value moment of inertia by substituting. The value is almost 2.21 into 10 power minus 3 unit kilogram meter squared. Similarly the rigidity modulus is going to be find out by using this formula and substitute this corresponding value. 8, pi value 3.14, I value is moment of inertia already found out, L by t squared from the first tabular column, r power 4 from the second tabular column. So from second tabular column only r value, small r value calculated, then r in power 4. So after substituting and multiplying the numerator and after multiplying the divided by the denominator value, you can get this is a rigidity modulus of the material of the wire, that is of the order of 10 power 10. So the number whatever may be, the important thing is the power should be 10 power 10 Newton per meter squared. So this is about the the particular torsion pendulum. After completing this, we want to write this result. So result, in this result section, what's the moment of inertia of disc, the corresponding value unit. Then rigidity modulus of suspended wire and the corresponding value and unit. So by this we conclude this particular experiment. And then short procedure about the particular experiment is also going to be right during the examination time. So just listen carefully about this and want to repeat. So First one is aim, the second one is formula, third one is about the explanation of aim, second one is apparatus, third one is formula, then explanation of formula, tabular column, then the experiment procedure, that means you want to do the experiment and fill that data, and finally calculation and result. So these are the things. So with the help of this, both the two values are going to be calculated, moment of inertia of the disc and rigidity modulus of the wire. Okay.